Okay, so, continuing from my left off and just recap with more calculations and related info. That's what we were looking at. And to clarify, we have, of course, natural and synthetic types of fluids, which are designated as pure fluids, and then we also have mixtures. So it's either you have an actual chemical compound which is in gaseous or liquid form that is pure, or two refrigerants can be mixed together, or two different compounds can be mixed together to make mixtures. But anyway, that's not what we're going to look at today. So at least at this moment, we're going to look at the simple calculations that you need for this whole thing. So now, the simple calculations can be explained simply as follows. So we're going to use this as an example. Before you do that, just from this chemical formula. Or and when you get the chemical, you can also give the name depending on how you that. But anyway, just going to focus on moving from this to this. So this can be represented in general as this. Most refrigerants take this form. Sometimes they might even have a letter there or not. But anyway, typically this is what you expect to see. So now, based on this, you need to understand that each letter represents something, can be used to calculate something. So your X is what you use to calculate the number of carbon atoms that you're going to have in a compound. Your Y is what you use to calculate the number of hydrogen atoms you have in a compound. Or your Z is what you use to calculate the number of fluorine atoms that you have in your compound. This is CHF. And then the other thing that you also need to calculate is the number of chlorine atoms you have in a compound. Now, this does not mean that every compound will have these. Sometimes you might find that the number of chlorine or fluorine atoms that you have is actually 0 and stuff like that. So anyway, let's continue. So this doesn't occur directly. For this, it's direct. Your Z will give you, so for example, if you have R1, 2, 5, if you look at this, this is actually implying that your 5 here is the number of fluorine atoms that you have in this particular compound. But your X and your Y, there's a calculation that you have to do, and it's simple. What you do is whatever value you have there, in order to find the number of carbon atoms, you say X plus 1. So in this case, you would say 1 plus 1 because your X is 1. If there was a 5 here, your X would be 5. If there was a 5 here, your X would also be. If there was a 5 here, your X would also be 5. But anyway, so based on this, it's like this particular compound has 2 carbon atoms. Then your Y, you say Y minus 1 gives you the number of hydrogen atoms that you have. So in this case, your Y is 2 to be 2 plus to minus 1. So that means whatever compound this is going to have one hydrogen atom. And what we're doing is we've been given a number, and now we're trying to obtain, using that particular number, the chemical formula. The chemical formula is a combination of some of the letters on the periodic table, if you get what I mean. So anyway, our Z in this particular case would probably be equal to 5, because for Z it's just direct. So anyway, as I was saying, from here, it's now a matter of determining what chlorine is. Now, the way you determine chlorine is you say the number of chlorine atoms is given by Cl is given by 4 minus the sum of your hydrogen atoms and your fluorine atoms. In other words, you add these two. Mind you, we mean the number you got here. Here you go 1, here you go 5. So in this particular case, you say it's 4 minus 1 plus 5, which would probably give you negative 2. Now, notice that this can't have a negative number of atoms. I don't think so. This probably only came about because this is actually just a random formula that I give you. Now we're going to actually practice on particular compound. So we go back to the typical formula of H2. Now the other thing, if you know something like this is the same as saying R0. Now the way you can remember this is if you're given a number like 11, if you write 1 1, it means you haven't changed any. So in this particular case, the same principle applies. If you write 2, but if you say 11, you can't write this as, for normal numbers, you can write this as 110, because 11 and 110 are not equal. I hope that makes sense. So in this case, if they say determine chemical formula for R22, we're going to say solution R22 is R022. So that means box is X, Y, and Z, which is actually C, H, and F. So if you remember correctly, X, Y, Z, this gives you a carbon, this gives you hydrogen, this gives you fluorine. But if you make it for fluorine, the value is direct. So in this case, since you have a 2, even the number of fluorine atoms that you have in your compound is actually 2. But for these two, we said for the one on top, you say X plus 1. In this case is what? 0. If you remember, this is 0 plus 1, we give you 1. So this is the number of carbon atoms that you have in this compound. Then say Y minus 1. You have 2 for Y. So 2 minus 1, giving 1. This number of what? Hydrogen atoms. Then you also determine your chlorine. Your chlorine, number of chlorine is given by 4 of these two. So in other words, the value you got here and here is going to be H plus F. So this is actually 4 mass atoms have as 1, and 4 atoms as 2. So this gives you 4 minus 3, which is 1. So fluorine and chlorine. And the number of amino acids that you have here, one there, two here, and how many here? One. That means this is actually ClF. We said how many chlorine as we have, and one more, the hydrogen. So but I'm assuming this is not how it's operating. It's supposed to maybe chlorine. How many chlorine atoms do we have? It's two. Yeah, I'm thinking it should be something like this. Fluoro, difluoro, hydrocarbon. This is how it's supposed to be. With the name something like chloro, difluoro, hydro. Basically how you do this. Now to try the example they gave. So it will give you, I think they give Cl2. Yeah, I think here it's 134. To give you C2H2 F4. And the letter it just implies that the stands for, I said molecules having same component but different atomic arrangement. So that means you're looking at them having the same chemical formula, but the way atoms arranged. For example, just a random example. I'm not saying this is how things work, but this is just a random example. So maybe if you are talking about arrangement of atoms, 5 atoms, and then you have 5 arranged in a. So this may be the isomer A, this may be. So there are the same number of atoms. I hope the same number of atoms. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. But if you write the chemical formula, that's why we get R for A. So I think what I'm looking at, it supposed to have R184 on its own, just like that. But I think this video we've discussed what we're to look at with regards to calculations. So thank you so much. Have a wonderful evening.